So I'm going to keep moving. See if you guys are seeing this. I'm off my Zoom screen now, so I'm just in the webinar. Ed, why don't you unmute yourself and just tell me if you're seeing the slides advance?
I
And
am. Yep.
good. Thanks, Ed. So at Hale Holdings company history, I already mentioned the 4 companies based out of a family-owned business here in Iowa, where I'm located. And I cover all 4 of these areas. And we have a lot of people on our sales team, inside sales, outside sales, and our logistics for warehouses and trucking. This is the part of the country where we're located most often and where we have offices are listed on the left. And we actually have friends that do what we do in the gray areas that are shaded there. So if you have a project, if you're located one of these areas, but you have a project somewhere else, we could probably still help you. So we're trusted advisors for anyone, anywhere. Welcome to the family. Our solutions connect with either erosion control, stormwater, all types of infrastructure. And we're blessed over the last several years that we were already good and we got even better at all of these things, strategically, surgically, delivering what you need, where you need it, when you need it, which is hugely important, especially on busy corridors or in crowded downtown spaces. And we're blessed with a lot of inventory. So when some of our manufacturers come to visit us, we get to show off a little bit and show them what all we have. I'm going to jump into a project that I presented at IECA National Conference in Richmond, Virginia earlier this year. And it's already been renamed a little bit. They've dropped the name Mall out of the 16th Street Mall project. So I asked for your forgiveness. You'll see a couple slides where we might still have that word on it from earlier presentations. This is downtown Denver. Thank you to Molly Veldkamp and the team at Dig Studio, PCL, Martin & Martin, and several others, Brightview, and the City County of Denver has other people that we want to thank. They provided a lot of this information. I'm going to run quickly through this background because it's going to kind of overlap with what Ed's going to talk about. We're going to complement each other. Downtown Denver's been there a long time, folks, and that 16th Street has been their main street, for lack of a better term, or for any other place that would be called that. And we've watched it evolve. And as it got heavier loads with buses and trucks, that old paving, that old subgrade, that old infrastructure system just took a beating. Wildly popular as they turned it into the mall concept to do a lot more public transit and get private cars off of there. But the buses got bigger, heavier, and the pavers underneath, as you can see in this picture, just took a beating. And it became a real maintenance challenge for the city, not only to try to maintain and replace those pavers throughout the years, each year, all the seasons, but with the infrastructure underneath. So why did they do this project? It wasn't because of us. And what we're going to talk about, we just were blessed to be a part of it. Their pavers were failing. And when they tore those out to redo them, they knew they had an opportunity to revisit a lot of the old underground utilities. And let me tell you, they found a lot of surprises. There's a lot of things that didn't show up on the maps. And the city of Denver worked with Downtown Denver Partnership, all of the many owners on the street, all of the utilities that had a vested interest, lots of organizations that just had their eyes and hands on this. It was tremendous amount of effort, driven mostly by safety for the general public, which is what we as civil engineers do, and mobility. They wanted people to access this site and they wanted them to be safe doing it. I have friends and coworkers who live out there, and they have family members of varying abilities to get around physically, and it was a concern. So much so that some of the families I know said yes, when this got publicized, that this was part of the motivation for this project, they said that they had stopped visiting down there because of deteriorating conditions on the surface. They didn't even know about deteriorating conditions underground with the infrastructure. So hats off and blessings to everybody involved with this project. It's taken many, many years to plan it and develop it, but they have made it to where this area is now thriving for everyone who has a vested interest in being a part of downtown Denver, even if it's just tourists coming through to visit. But the people who live and work down there, they're singing the praises of this project. I mentioned the pavers. There's a lot of history into the art and the design of how they came up with this pattern to represent the back of a snake. And that's a nod to their heritage and respecting their history. But I'm so proud of this project. This picture was taken before this was open to traffic. They just put the planters out there and had the trees planted and got the light poles erected. But you'll see some people off to the sides and some of the workers on there just getting this ready to take away those orange barriers and open this to the public. I was one of the first people to get a tour it with the ASLA, the American Society of Landscape Architects Denver chapter. Took us on a tour a couple summers ago before they opened it to the public. It is beautiful, really amazing. They did everything they said they would do. They even invited people from the community to help make sure that their design, if you look in this left picture, is a test mock-up section of what they proposed. It was going to work for ADA accessibility. Pardon me, I talk too much, so I drink a lot. It's water. But this solved their needs. And as an engineer, underneath this is an amazing, impressive, strong, permanent design system that can handle stormwater, not just in that little line there that shows the slot drain, but through all those grooves between every paver, there's permeable grout in there. So it's taking water in through the surface, going to go into these tree cells. We're going to talk a bit in a minute, and eventually going to go down through the storm sewer, cleaner, cooler, reduced flows, slower velocities into the river, which is then going to continue all the way to Nebraska. But this 3D model that they used was incredible. All the color coding that Martin & Martin and other engineering firms worked with Dig Studio and all the utility companies in the city, county of Denver. As they mapped this, they found basements and foundations that extended into the right of way that weren't part of the original plan. They had to navigate that with all of these utilities. It was amazing what they had to do to accomplish that. On the surface, right below those pavers, is a very innovative system that I've not been a part of yet until this project, with drainage grooves through the concrete base that's below the pavers, so that as the permeable joints brought water through the paver system, it didn't stay there. It follows these drainage grooves into the soil cells for the tree pits and eventually into the city storm sewer. This is one of ours, very proud of it. Brightview was a subcontractor for PCL, and they protected every one of these tree openings even after the tree pit was installed or the tree was installed into the pit, until they were able to get the grates put in that Ed will talk about briefly, and then get the pavers put on there for the finished product. Public safety was number one. They had walking pedestrian corridors on both sides of this during construction. And once they got the inside done, they had to move the construction to the outside and put the pedestrians on the inside. So as you walked it, it was a maze, but it was amazing. And that's not planned. I'm just winging it. That was continuing public access. I'm a little further into this than I wanted to be. Slot drain, I'm going to go quicker so I can hand it to Ed. This is an aerial view showing the drainage grooves on the pavement, shows the tree pits. This is when they're planting the mature trees that they'd already had on their own property in the city for 5 years. So it was already acclimated to their weather. Once they put them in, it looked like they'd been there for 5 years or more. This was then open to the public, and you couldn't tell these were new trees. There it is. This is a beautiful place, well used. I have videos on this. I'll go faster. I'm so thrilled to know Dig Studio and their team, who made these comfortable, welcoming living spaces. Ed, I know you're going to be short on time. You can unmute yourself. I have 2 slides before I introduce you. This is one of the old original design concepts that they'd done when they talked about the mall concept with pedestrians and buses. But they had the old school tree pit, which we now call tree coffin, because it didn't allow for the expansion of root growth through healthy soil. And so it would have stunted the growth, and did stunt the growth of those trees. Dig Studio provided this beautiful graphic that shows the project ecosystem, out of sight, out of mind to all the residents. So the people of Denver probably think they just put back in the same thing they had before. Nope. This is innovative. You can see where the soil mass is for the trees, the structural cells holding up the load of the plaza and the street, and the drainage is a part of that as well. And all of this stuff got buried and hidden from the public, but we know it's down there. And these are going to be the healthiest trees downtown Denver has ever seen. So with that, Ed, I'm going to hand over remote controls to you. And I didn't have a bio for you, so let me just give it over to you. There you go.
Wonderful. Thank you, Bill. Please let
Yeah,
me
buddy.
know if there's any issues with the audio or
You
anything
look
along
great and you sound great.
Well, I woke up this morning. I'm based out of Seattle, Washington, and so it was raining cats and dogs outside. So we brought in a little bit of extra light just to try to, not look like I'm sitting in a dark room. Really appreciate the introduction there. Let me see if I've got controls here just to make sure that I can move the slides, and I can.
It's working. There'll be a little bit of a lag since it's running off my computer. So give yourself 6 to 7 seconds, but it's working great.
Gotcha. Okay. So I'm going to kind of slow things down a little bit. I'm going to back the bus up, as they say, because one of the core functions of my role is I get to meet. I have the distinct honor of getting to meet with city planners, civil engineers, landscape architects, a lot of times at the very, very early phases of planning. And so through the course of that, we do get to learn a lot about each individual region here in North America, so Canada as well as the US, as well as the specific challenges that are inherent within each and every project. And so from that standpoint, I'll back up just a hair here. Because one of the key things that we hear more and more is in terms of bringing projects together, green infrastructure designed in with critical infrastructure is fragmentation. And so the more that we can work towards alignment across departments, across firms, across stakeholders, as we all know, none of these projects come together in a vacuum. There's a lot of people working to collaborate to take these projects from vision to implementation and do it successfully. So from that standpoint, I'll kind of start slow and then we'll speed up as we go along here, especially respecting everybody's time. So one of the key drivers that we see that's an overarching theme throughout all of this is urbanization. And so what that speaks to is that currently over half the world's population live in urban areas. By 2050, that's expected to exceed over 68%. In some cases, I was recently in Texas, Houston, Dallas, Austin. And so Texas, if I'm not mistaken, they're currently sitting at about 84% statewide. So for all the land and for all the vast expansion that Texas has access to, a lot of the population concentration is in urban environments. And so what that does is that it puts a lot of emphasis on addressing the challenges of rapid population growth and urban density. So essentially, all eyes on you, all eyes on us in terms of designing and conceptualizing the coexistence of green infrastructure alongside critical infrastructure. I tend to say, and I tend to joke around a little bit, but I tend to say that we're in the conflict resolution business because historically, we started back 25 years ago in looking at this space or evaluating this space. And historically, there's been this thought process that critical infrastructure, in other words, people-made infrastructure and green infrastructure don't play nice, that they don't play well together. And what we're finding is that over the course of, again, over a couple decades of doing this, is that that's not the case. This really is more a story of integration is really what it's about. But it does go back to best practices, use case, and how these things get implemented. So for the sake of what Citygreen does and what we cover in this presentation is we're all about getting trees in urban spaces. And about 12, 15 years ago, we started with stormwater integration, and we'll get into some of the reasons why we do that. But the drivers, again, the reason why we get municipalities, developers reaching out to us is a lot of times these are some of the key elements that they're facing. It's the development of housing developments, mixed-use developments, declining infrastructure, extreme weather events, or prolonged weather events. You look at places like New Orleans, you look at places like Texas, where two different sets of climate, but very, very similar challenges in terms of prolonged weather effects, how that weather affects the infrastructure. So consistent flooding, stream improvement plans, degrading sidewalks. We're going to talk a little bit about that. But the key to all of that is that what that does is it places the focus on sustainable development. So in essence, building things to last. I won't go into all the details of trees and green infrastructure, but I do tend to start in terms of that alignment, making this point is that we tend to view at Citygreen, we tend to view trees as nature's technology toward climate resilience. In essence, regenerative infrastructure. And we're not trying to play semantics. We're not trying to come up with our own terms. What we find and what we have found is that historically, trees had been viewed, when we first got into this space, trees were viewed as a nuisance. They're going to tear up hardscapes and they're going to die. So now we got to go in there and repair, make repairs to the infrastructure, and now we got to replace that tree. On better terms, they're viewed as decorative elements, ornamental, and while they certainly are those things, while they do tend to beautify spaces, they're a lot more than that. And so when you view them in terms of regenerative infrastructure, when you consider what the tree canopy does, what the root system does in the soil, all of a sudden you're looking at reframing that dialogue in terms of what this tree actually does, along with the soil, along with the water filtration. So for the sake of what trees do, just in essence, is they provide shade and cooling, carbon sequestration, air and water purification, human health and well-being. There are now data sets that are correlating the positive effects of having green infrastructure in any given community, especially when you tie in the effects of respiratory illnesses. And ultimately, that all leads to contributing to economic modeling and viewing trees as assets versus versus liabilities. But the vast majority of the time, when green infrastructure elements were going to be removed from a project, it was that value engineering phase. And so again, instead of looking at trees as ornamental design elements, looking at them as part of a component of infrastructure, all of a sudden it does change that conversation about, well, let's take a look at this. What does this actually look like? What does it do to any given community or any contributing or collaborating infrastructure, integrative infrastructure, and in turn back to that economic modeling. We'll stick with this a little bit further here, so please bear with me. It goes back to essentially getting folks aligned, and then ultimately we'll jump back into products. But so looking at environmental challenges, I tend to try to pull data from each individual region that we visit, because just like there are individual challenges are unique to any specific area, the data that's compiled to essentially justify, look at cost modeling or return on investment modeling, is also something that is still in development, but not necessarily standardized. And so in this case, we're pulling from Denver. So as of a 2023 study, 2.2 million trees valued at $2.9 billion in structural value. That's important, and I'll get to that here in a minute. So Denver does have some pretty good data on that. Sticking with that, two key things here that come up are that Denver's urban tree canopy, and I think that this report is a little bit unfair in terms of that headline. I've been to places where the numbers are much lower than that at 15% canopy cover. Really what we're seeing, I think, is 7 to 8% is amongst the lowest, and I think 48 to 49% is amongst the highest in the US in terms of canopy cover. But what it does speak to is it speaks to two key things. In that same report, there's an emphasis on comparing old growth trees versus newly planted trees. And so old growth trees are going to absorb 100 times the amount of stormwater runoffs. They're going to sequester 30 times more carbon and absorb 25% more pollutants. And so it brings up two key things. As we speed through to keep up with housing demands, back to that urbanization point, two key questions come up. Can we keep existing trees, and can we bring new trees up to speed as quickly as possible? And the short answer to that is yes. And we have some case studies that can illustrate that point where we've been involved in projects like that, such as here in Seattle, Climate Pledge Arena was a prime example. We've got some other projects throughout the world as well. But that speaks to being able to address those two key points. The last point here on economic modeling, again, data is going to vary from region to region, but here in the Pacific Northwest in British Columbia, so just north of us, there's an organization called Metro Vancouver. They're a nonprofit organization, and it is one of the key points that I do try to make, that with Citygreen, we take an engineering approach towards problem solving, and so we do rely very heavily on addressing challenges that cities will present to us, or developers will present to us, or contractors will present to us, and we take that into account in how we design our products and how we help support the implementation of green infrastructure. So we also collaborate with nonprofits and universities. And so in that sense of economic modeling, Metro Vancouver is an organization that have conducted some studies where they help collaborate with 21 municipalities and 2 First Nation organizations in British Columbia, where in compiling some of this data, they have quantified some numbers here for that. Every dollar invested in trees, you're looking at $1.50 to $3 return on investment, which is pretty significant. That's a 50% to 300% return. When you're looking at the cost of putting in green infrastructure combined with compared to gray infrastructure, you're looking at $5 per gallon versus $10 per gallon. So close to 50% savings on that upfront cost. So when we talk about economic modeling, it's not some vague, while the data sets have not necessarily been standardized nationwide, there are organizations that are publishing this information and are putting this information forward, so that it does speak to that point that there are direct cost savings and indirect cost savings attributed to green infrastructure implementation. So jumping into Stratavault a little bit here. We at Citygreen, we tend to view us coming into this space as pioneers. We started to evaluate this space 20, 25 years ago. and developed a framework. That's essentially what Stratavault is. If you're not familiar with soil cells, or in this case, Stratavault, it's a framework designed to uphold, to support hardscapes while allowing for a large void space of uncompacted soil to allow the root systems, tree root systems, to access that uncompacted soil and high nutrient soil. So what we know from our good friends and that are forensic arborists are that tree root structure and tree root health are not the same thing. You have to be able, in order for the survivability of that tree, you have to give that tree root system the ability to do both, to grow in structure as well as access to an uncompacted soil. And so hence, Stratavault is our 6th generation product that accomplishes that. And what qualifies us to speak to be a planning partner, design assist partner, and ultimately supply companies like ASP, Bowman, Cascade Geo with products such as ours for soil cells, is that we've been at this for a little while. So we've installed a little over 3,000 projects worldwide. The key strengths about Stratavault, and we'll get to this here in a minute, because we're not the only products that are on the market, and that we tend to view that as a wonderful thing, because at the end of the day, this is about folks coming together and building, helping to build communities that last and in a more sustainable way. But there are some distinct differences between what we do and what other folks do, and so the key strengths about Stratavault are load capacity, services integration, modularity, and regulatory compliance. And so as we go through the course of these projects here, we'll touch on some of those things. So I will tell a little bit about our story, because it speaks to where we are today in terms of what the future holds, and how we can help contribute to this particular emerging space. So Ben Gooden, he's our CEO and founder of Citygreen. He's an engineer. And so 25 years ago, a little bit over 25 years ago, City came to him and said, hey, look, we have an issue with these trees in our cities. What they're doing is that they're tearing up these hardscapes. What can you do about that? And so Ben took a look at the issue, studied the issue, and found that tree root systems tend to sprawl out quite surface level. And the reason for that is that they tend to prioritize reaching oxygen over water and nutrients. And so therefore they're tearing up hardscapes. So developed a root director here. It's 36 inches in height. And what that did is it allowed that tree root structure to get down below the hardscapes and then sprawl out. Okay, that's a wonderful thing. But now, moving forward, a little bit of a bigger issue came up. Okay, thank you for that. But now we've got 8 out of 10 trees that are failing within 5 to 10 years. What can you do about that? So in studying that issue, it goes back to that first point that we covered, in terms of providing that root system access to be able to build a framework and access to uncompacted soil. So in studying the issue, what he found is that trees tend to be planted in a very tightly confined space. And secondly, is that they tend to be planted in a media that is very heavy in rock content. So a structural soil, an engineered soil, if you will, which is great for holding up the hardscapes, but not great for allowing that root system to grow both in structure and accessing an uncompacted high nutrient soil. So that being the case, that became the advent of, again, this is our 6th generation, but it became the concept of, okay, how do we build a framework, a matrix that is modular, so it's an off-the-shelf product, but can be applied as a custom, element to each project, because every project is different. And so essentially, it's like Legos, if you will, of taking and we'll get into this here in a second, but taking a waste material and turning it into something useful in terms of green infrastructure. And so coming up with Stratavault, what we find is that we're between 93 and 95% of soil volume. That's the void space that's allowed within the framework, versus a 20 to 40% for structural soil. So all of a sudden, what the end result is, what you're seeing is that you're while holding up the hardscapes, you now have a framework in order to allow that tree root system to grow. And one of the key things to point out is that very early on, it does go back to this economic modeling. Folks would say, okay, that's a wonderful thing, but structural soil cost is going to be here, soil cell cost is going to be here. How do we justify that? Well, when you start from the essentially working it backwards. When you start from the end goal of what's the efficacy of that tree or the survivability of that tree, what is the soil volume going to be required in or under both media in order to accomplish that? And so when you find that you apply that same math to the both different media, what you find is that you're going to need a larger soil volume with structural soil than you are going to be with soil cells. And so we tend to say, don't take our word for it. Go on our website. There's a soil volume calculator and plug in the numbers, tree canopy size, what that translates to into soil volume. And in turn, now you're looking at both media and the cost on both. So now when you're comparing the cost, just the cost, not even plugging in return ROI models, you're now comparing things that are a little bit more closely related in terms of apples to apples. So that's one of the key things, one of the key challenges that we addressed early on. And what you get, and so here's an example, here's an illustration of the framework going in. You've got your uncompacted soil, you've got your subbase, your drain pipe, the liner here coming in over the top and supporting the hardscapes. And what this image on the right demonstrates is one of our tree grades that we designed, which allows for pavers to sit in it, which it gives you a very nice aesthetic look, but it gets the point across. Getting trees in urban spaces, back to that integration of hardscapes and living organisms, in this case, trees.
Hey, Ed, you're doing
So,
great on timing. We're right at the halfway point and it looks good and sounds good. Just an update on timing. Thank you.
okay, thank you, Bill. And so here's a really good point of illustration and a presentation versus real world. And so, Bill, I'm really glad that you highlighted and showed some of those diagrams and some of the images from the 16th Street Mall, because this slide is specifically designed to demonstrate the how Stratavault or how utilities integrate within the framework. And so very large open void space, not just to allow for the tree root growth, but also to allow for integration of services and utilities. And so in this case, it's a very nice, clean tube, a very nice, clean looking pipe coming through. We all know that in the real world, that's not what it looks like. What it looks like is spaghetti. I've literally had engineers send me images from a job site where they've dug a trench. And you're going to see, things that look like spaghetti basically going through. And so one of the key things is it's not unlike TVs back in the day when, you had DVRs and all these other components tying into it with a little bit of routing, a little bit of channeling. Those utilities route through really quite nicely. But the idea here is that it's one of the key strengths of what we do. One of the questions that we get, because we're not the best known product on the market. In some ways, you could say we're one of the best kept secrets on the market. And again, it goes back to just our approach of taking an engineering approach towards problem solving. It's not something that we're necessarily loud and boisterous about. It's really more about how we stay focused on those challenges at hand with the clients that we work with. But one of the key things that does come up, and it is important in terms of application, is that strength. We have the strongest product on the market. The way that our products are designed is it's a modular individual pieces with 4 legs, so they can stand on their own. And then we have they're 2 feet by 2 feet in length and width, and then 16 inches tall. Then we have a flat foot plate, 16-inch foot plate, 8-inch foot plate, and 16-inch foot plate. So now we can go as deep as necessary in terms of soil volume. But the key thing about that, and what you're seeing here on this slide, is that we do our structural load testing without the soil being inside of the matrix. So we don't need the soil in order to get the structural integrity out of it. Our products are HS20 and HS25 rated. And again, that's important because in places where we are not the best known product, municipalities have essentially said to us, well, we didn't know that there was a product that was HS20, HS25 rated. We've essentially relegated soil cells to only going underneath pedestrian load-bearing traffic areas, not parking lots, not anywhere where you're going to have vehicular traffic load bearing. And so that is a key thing, that it does open up the areas that you can design in green infrastructure elements. Along those lines, so as I mentioned, our modules are designed to be standalone. At the same time, we do have bridges that connect them laterally. The vast majority of the time on any given project, so this is upwards of 95%, we are going to bridge the matrix laterally, and the reason for that is to spread that load. We're going to look to make the framework as strong as possible any chance that we get, because the idea here is support those hardscapes and account for all the various conditions that are going to, that could be a detriment to the structural integrity of those hardscapes. So anything that goes underneath, we're absolutely going to make sure that we're building as much strength into it as much as possible. Along those lines, we also have a partnership with Ocean Legacy. They are a nonprofit organization based out of British Columbia. They pull millions and millions of pounds of plastic out of the Pacific Ocean in partnership with nonprofits throughout the U.S. as well. And so a lot of this is ocean or fish netting, I'm sorry. And so they work very, very hard at pulling these pollutants out of the Pacific Ocean. And so in partnership with them, we now have the ability to manufacture our products with the use of ocean legacy plastics. And that speaks to just inherently how we've done things from the very beginning. The concept of, hey, how do we take a waste product so that we're not adding more? How do we take a waste product, turn that into something useful in terms of green infrastructure? So what that speaks to is responsible manufacturing. We do manufacture in Australia, we manufacture in Canada, and more importantly, we manufacture here in the US, which that 16th Street Mall project, if I'm not mistaken, it's a Build America, Buy America Act project. And so therefore, from a regulatory compliance, we have the documentation that supports that. And it's not something that we did as a knee-jerk reaction, to any new trends or anything along those lines. It's something that we, from the very beginning, have. That's the way that we positioned ourselves. Because we believe in local supply chains. And so again, in partnership with Bowman, the ASP, the Hale family of businesses. I won't say all four names every time, but the Hale family of businesses.
I don't blame you. It's hard. You're doing great.
We've got the product here in the U.S. and manufactured in the U.S., but readily available. And again, I cannot speak highly enough to what that means in terms of getting these projects into the ground. So this is where things I'll kind of speed up a little bit here. So that's all well and good. How do these things actually work? So what you're seeing there is the tree on the left, same tree species as the tree on the right, same parking lot, same gentleman. And so this was done in conjunction with a city. This is in Australia, so battle tested. Australia is where we're originally from and still have our corporate headquarters there. We've been experiencing in Australia a lot of these extreme weather events and patterns or whatever for some time. And so that's essentially ground zero where we got started. But that was one of the key things that we first looked at was, okay, can we tie an economic model to this? What does that look like? And so with a city, with a university, tree on the left, they gave it a $510 valuation after 15 years worth of growth. Planted in standard and traditional planting methods. Tree on the right, planted in soil cells, represents 4 years worth of growth, and the city gave it a valuation of $17,500 each. So number one, huge difference in terms of look at that tree canopy, look at that tree growth within 4 years, back to speed of getting those new trees up to speed if you can't avoid tearing down the old growth trees. But secondly, it marked a fundamental shift in how the city could view those trees as a value attributing asset versus a liability. And so now, again, as we started the presentation, we looked at the city of Denver's tree inventory and the structural value that is attached to it. And so that starts to open the door towards economic modeling, which is really the forefront of where this is all going. So back to efficacy here. So 2013, exact same street. I don't know if you can tell, but on the left-hand side, there's a tree by the red car, a tree by the blue car, and then over here on the right-hand side, there's a tent there, and there's 2 trees that were planted. So trees on the left were planted in traditional media structural soil, whereas trees on the right were planted in soil cells. And we'll see if we can get this time lapse to go here.
Let me know if I need to click on it. It looks like you got it going now. There it goes. I'm sure there's a bit of a lag there, Ed, but you can see it. It looks great on my end.
So yeah, it looks like it completed its course here. So I think that was 9 years, 10 years. So looking at the trees on the left, they're relatively the same size as when they started, versus the trees on the right are significantly larger in terms of that canopy cover. So back to that regenerative infrastructure doing what it's supposed to be doing, providing the shade, providing the cooling, providing the carbon sequestration, providing the water purification. That looks more, you want that infrastructure to be as robust as possible, as well as decorative. Oh, there was some lag here, so let me back up. So another key thing is that, and this was one of the things on 16th Street Mall, so we also do design structurally engineered tree grates. And again, it wasn't something we woke up one day and just said, hey, let's go do this. It was addressing a challenge, addressing an issue there of what can we do in terms of versus cast iron, which is what tree grates tend to be. And there's a really good reason for that. These you have to take the economic factors into this equation. But there are cases, especially now when you start looking at ADA compliance, where number one, you get the aesthetics, you get the protection, and you also want the compliance element of it. So we structurally engineered tree grates made out of stainless steel. This happens to be one of our models here. Our most popular model, sorry, I'll get to that here in a second, is this Invisigrate, which allows for pavers to sit in, getting that very nice, clean aesthetic look. But the key to this is that we designed these tree grates not just to be structurally engineered for that load bearing, but also heel safe, slip resistant, and ADA compliant. And that's one of the key things that we started with, is that a lot of times we get municipalities coming to us saying, we've got these sidewalks now that we got to figure out what to do. These trees have torn them up. And so if we're going to go through and repair that concrete, we might as well take a look at what we're going to do with those trees and what we're going to do with making those improvements, so that we're not in this situation again moving forward. And this is a lot of the driver that came behind these tree grades. I won't necessarily go into all of this. This is just high level, kind of a quick recap of achieving what we're doing in terms of getting trees in urban spaces, along with stormwater integration, is achieving twice the tree canopy in half the time, reducing urban heat island effect, zero pavement heave. So again, we're protecting that infrastructure. Flexibility to work around services, again, utilities integration. That's one of the key drivers to all of this. That's great, but how does it integrate with? We've got power lines running through there. How do we do that? Drought resistant root systems, supercharged carbon sequestration, and of course 100% recycled plastics. Oh, okay. I won't touch on this.
That looks familiar.
Yeah, Bill, you did a great job of covering this. I don't know if you can tell, but in this picture here, you can see some Stratavault down there below the infrastructure. Okay, Clematis Street. So we were just in Florida here a couple of weeks ago, met with the city there, and just a prime example of a street improvement project here that I believe it's 4 years in, and it's just a great example of that alignment between the engineers, landscape architects, city planning, and it's just I wish I had a picture here of what the finished product looks like. But this was really just to illustrate what a large scale project looks like going in. But Bill, I think you covered that already pretty well. So here we go. There's a couple of videos here. I'm going to let these two videos play. What they speak to is use case scenarios in terms of stormwater integration. So we'll jump into these.
I'm going to mute my speaker so the audio doesn't reverb, but go ahead and click that if you can.
Okay.
It's going.
The project name is Kinsman Sports Center Rehabilitation. One of the big components of the project is the renewal of the building. Our scope included the renewal of the parking lot. The original project vision was creating that urban tree canopy in the river valley context.
The challenges that the client was trying to overcome were putting trees in hardscape and narrow medians in a parking lot, which brought us to soil cells. We realized that the current stormwater system discharged directly into our North Saskatchewan River.
We saw an opportunity to implement low-impact development to deal with stormwater management, but also to ensure that whatever trees were being proposed, they had the adequate soil volume.
Collecting the stormwater was very important. We had to find somewhere to put this water and have to design for a 1 in 100 year storm event. So it was paramount that we were able to hold as much of that water as possible within the soil cell structures. We chose Stratavault for this project for several reasons, but the main ones being the module itself being made out of 100% recycled plastic is obviously much more sustainable than using virgin plastics. In an application of parking lots and drive lanes, the structural ability of Stratavault was much superior than other products we encountered. Because of the void space of the individual modules, we were able to achieve the soil volume requirement and stormwater retention requirements much faster with fewer modules.
In areas where developers have to work not only for soil volume targets, but also stormwater targets, the Stratavault will allow them to achieve both of these in one investment. With these cells, whether in a parking lot or a curb cut installation, you can direct your stormwater into the cells, allow the trees to deal with the stormwater.
How we got the stormwater into the soil cell structure was using existing catch basins that were fitted with Stratavault shields, which is a grit separator and distribution system that filters water into a perforated distribution pipe that creates a network along the surface of the soil cell structure. Water then percolates into a high filtration soil, which is a high sand soil, which in turn feeds the trees.
HML loved working with the Stratavault product. It was really easy to deal with and work with. The project seems like a very sustainable environment that is going to be extremely successful.
Citygreen's design service is actually brilliant. In this case, Citygreen's understanding of the city of Edmonton and working with the local municipalities and their requirements made it even easier to get the design approved by the authorities that need to do so. I think this is an excellent way of designing parking lots going forward. The runoff from parking lots tend to be higher in contaminants, oil, grease, grit, salts, just from winter practices in a winter city.
Greening up the parking lots just helps kind of warm up the environment in terms of adding shade for the cars, and it's nice to have a soft landscape environment that's welcoming and it's not just like a covered concrete.
You may have trouble getting out of this. To get back into the PowerPoint, you'll have to hit escape, and I might have to help you with that.
Okay,
Go ahead and try to advance to the next slide. There you go.
there we go. Thank you.
Yep, you're doing great.
In this section, we will give an overview of the integration of trees with stormwater harvesting. It's a really big subject which we can't encompass in this brief session. We will certainly cover the main principles. Our cities are designed in a way that when it rains, the water is directed away into catchment basins and pipes, which leaves street trees without rainwater. At Citygreen, we have designed a paved tree pit structure that allows the tree's root system access to the rainfall. This design presents an opportunity to restore pre-development flows and improve water quality within our cities. The design enables rainfall to be directed through pavements into the tree pit and then become accessible to the root system. This supports the continued health and growth of the tree to cool down the neighbourhood and promote evapotranspiration. The interconnected design recreates natural environmental cycles and facilitates rainwater harvesting. It's important to understand the difference between passive irrigation, water balance, and stormwater harvesting. Passive irrigation is the practice of intercepting some water and directing to the tree for expected benefit of the root system. This is good practice, but leaves many of the benefits untapped. Water balance is the calculation of moisture demands of a given tree type and soil volume against the climatic data of a given region. This enables the designer to provide the optimal balance of soil volume and catchment area to ensure a tree will not be below wilting point for an extended period. Stormwater modelling is the use of proprietary software to create tree pits as nodes in a stormwater treatment train. This is the ultimate blending of urban forestry with stormwater engineering and can obtain significant cost benefits when incorporated into design from early stages. This rendering shows how we can intercept rainwater at the surface with permeable pavements. This is a good option that allows oxygen exchange, moisture to come through for the benefit of the trees, and some on-site detention. This image illustrates the way we can use catch basins, sometimes with filtration inserts in them, to intercept runoff from pavement and feed it via a pipe into the tree pit. Another option is to utilise trench drains to intercept pavement flows and feed into the below ground tree pit. Still another option is to utilise curb drains that can collect water that is running down a gutter and feed it through the green infrastructure behind the curb. The effective distribution of the harvested stormwater is a key part of successful stormwater tree pit design. Water needs to be introduced as high as possible in the tree pit pavement profile in view of allowing for infiltration downwards through the growing media. The two main distribution methods are piped and ponding. Piped systems deliver the water to the upper section of the tree pit via a circuit of perforated pipe, typically within a filter wrap. The advantage of this system is that the pipe can be flushed out if needed. Ponding systems employ a void space at the top of the Stratavault matrix to allow water to spread out and pond over the surface area of the soil media. This ties in well with most stormwater modelling programs. Utilising tree pit soil or growing media as a filter is a really good way of extracting additional value from a tree pit. By working with the correct soil specifications, harmful pollutants in runoff can be fixed in the soil and prevented from reaching delicate river systems. Tree roots and microbiology can play an active part in breaking down pollutants over time in a process called bioremediation. Another benefit available from using advanced tree pits is a concept called detention. Tree pits can be configured to detain or hold back water, as voids can be incorporated into the base of the tree pits to hold large volumes of water. In addition, the growing media itself can be specified in such a way that water is held within the soil between rain events. The combination of these functions can mean that downstream detention ponds or below ground storage tanks can be minimised or removed from the design. This can result in very significant savings to developers and enhance growth from the trees.
Thank you for tuning into the Citygreen course. We hope you found it beneficial, and please feel free to reach out with any questions.
10-minute warning there, Ed, for the very end of our webinar.
Yeah, thank you, Bill. Yeah, so on that, I go through these other slides very, very quickly or just skip through them. And the reason for that is we're down to 10 minutes. Want to be very respectful of anybody that has any questions. So if anybody has any questions now, or I guess, Bill, I don't want to throw off the model here.
Yeah, we'll get to it. You keep rolling, buddy.
Okay, all right. So I'll go through these very quickly. Grant covered this here in the video. Yeah, I tend to have these slides. I'm sorry, I'm not sure if I finished that thought. I tend to have these slides in case the videos don't work, and so usually that's how I talk my way through that. So I'll just go through these very quickly. So just different methodologies of getting stormwater into the tree pits. I'm not going to focus too much here on curb inlets. This was something that we designed for a project up in Edmonton in Canada, keeping the debris out. It's something that we're evaluating here moving forward as a product that we can offer to cover those large curb inlets. And what it does though is it speaks back to that engineered problem solving specific to a project. And again, getting debris out of those catch basins is something that contributes largely to reducing the cost of maintenance on the back end. Stormwater tanks, so here's an illustration of how Stratavault is now being utilized as well. This is a project also up in Edmonton. I was just there 2 weeks ago. I'm going to go through these very, very quickly. This is, again, in case the videos don't show, just shows you the process of what it looks like.
It's going through. There might be a little bit of lag there, but the animation is working on my end.
Okay. And so really, I tend to highlight this point here that, again, we didn't get into stormwater integration because we said, hey, there's a great space, let's go do it. We got into it as a result of two key things. Number one, hey, we have a very arid climate. What can we do to help out our irrigation costs long term? Well, let's capture that stormwater. Let's capture that rainwater. The second part of it is, hey, we have these flash flooding events. What can we do to help take a lot of the stresses off existing infrastructure? Well, let's capture that rainwater, bring it into the trees. And so from that standpoint, we're very different from most other folks that are in stormwater management, which is that we're all about slowing everything down. So slow that water down, get it into the tree pits, feed the trees, filter the water, and then release it into the infrastructure. Here's an example of a large-scale project in Australia, so Barangaroo waterfront. If you ever get a chance to visit, it's a beautiful area. Again, it seems a little bit flat in my view, just because we've already highlighted the 16th Street Mall, but this is what an illustration looks like of these, back to utilities integration, back to services integration on a large scale. This is what that looks like going in. And so here are the trees in 2016 going in. And here they are 2 years later in 2018. So back to the efficacy of those trees, getting them up and running and producing what they're supposed to be doing in terms of carbon sequestration, providing shade. I can't speak highly enough of our design team and getting the design team involved early in any given project. And the key for that is you want to understand basis of design, consider it design assist, if you will. It's one of the key values that we provide in conjunction, back to that continuity from concept to installation in conjunction with the ASP family of business, or sorry, the Hale Holdings family of businesses on the ground, is to keep that continuity from concept from concept to implementation. So construction drawings, shop drawings, we guide you through, we ask you to lean on us in terms of what we've seen across the board, across those 3,000 projects. This is what this looks like going in from drawing to application. And so with Disney, I tend to highlight that as a developer, they have a very, very high, stringent quality of standards. And so it's somebody that we've worked with here. They were an early adopter when we first came to North America. It's somebody that we've had a partnership for some time. And so from that standpoint of economic modeling, it makes a lot of sense to their developments in terms of investing in green infrastructure. And so that's one of the key things that we do try to lean on in terms of other developers. That seems to be a big part of the challenge, is how do we that municipalities will bring to us. It's how do we speak to developers in a way that makes sense for them, economic sense. And so while we cannot share that data, it is something that is at the forefront of the dialogue in terms of green infrastructure and what it's going to do for any given project. And so working through some of those elements of evaluating projects, here's one that comes up where a developer came to us and said, okay, here's what we're looking at doing in terms of the building locations, the tree locations, parking lots. And as we all know, space in any kind of urban environment is there's not enough to go around. And so in this particular case, there was a stormwater retention pond off to the side here. It's the illustration you're seeing on the left. And as Grant spelled out in one of the videos, in terms of applying, decentralizing the stormwater management underneath the tree pits, we were able to eliminate the need for that retention pond, and it opened up that space on the left-hand side there for development. And so significant value there to the developer. And so with that, in closing, Citygreen Services and the Hale family of businesses, so Design Studio cannot speak highly enough of reaching out and getting us involved to identify use case scenarios, what your best options are in terms of potential challenges, anticipated outcomes, future proofing, so building things to last, pavement engineering, got a particular hardscapes, installation Q&A and training. So once again, we lean very heavily on our distribution partner in conjunction to make sure that we've got ample support as these projects are going in. And then in terms of Citygreen projects, we're big on case studies. It's a nod and out of respect to the collaboration of everybody coming together, working to get these projects designed into communities and building sustainable communities. So with that, we say thank you, and Bill, turn it back over to you.
We got a few minutes left. Thank you, Ed. You just did a wonderful job, and your videos worked great. I was nervous about it, but no need. I worry about stuff that doesn't need to be worried about. A friend of mine, Pat Sauer, asked, can you talk more about the soil that's used inside the structural soil cells? She's asking if you want to share anything about percent of sand, silt, clay, or organic matter, or any proprietary components to the soil mix. How do you usually answer that, Ed? And then I have something I can add to it.
Sure. So we do have a soil.
Thanks, Pat, for the question. Go ahead, Ed.
Yeah, you're okay. So we do have a soil spec, and we can certainly provide that. It does tend to vary. It does tend to vary from region to region. A lot of that is because the soil is being pulled locally. So and that opens up a whole other conversation about native species, native soil. So you essentially take that soil spec as a guideline and then source that locally according to that mix. But ultimately, what it's going to come down to, especially with stormwater integration, is what you're looking in terms of hydraulic conductivity, what you want, the flow rates, how much water is going to be given in or is going to be coming in. That, in a sense, we do evaluate the soil media and then make adjustments accordingly or recommendations accordingly. You're going to have a more sandy soil in an area where you want that water to go through very quickly. You're going to change that up if you want to slow things down a bit. And so Bill, if you want to add to that, you're more than welcome to.
I do. Good answer. Thank you. So Pat, thanks again for the question. I will tell you, we've answered this in person. One of the things that Ed talked about at the very end on his second to last slide was Citygreen likes working with people on learning about installation and how to go hands-on. Before this Denver project, a few summers ago, with one of Ed's would have been former coworkers, we did a live presentation with Downtown Denver Partnership, the city, some contractors, and a bunch of people got to go hands-on and do a Stratavault assembly demonstration. Well, we did one recently, earlier this year in Fort Collins, Colorado, because it was requested, and they asked us to bring our in-house partner, Biosol, Rocky Mountain Bioproducts, Biosol. And Pat, that was because they have some sites where it's old, dead soil that doesn't have any organic matter and they want to revive it. And they wanted to know if we could incorporate biosol into that mix to feed the trees. And the answer is yes, of course. That's a great question. So I actually brought Tom Bowman with me from Rocky Mountain Bioproducts to talk about it. That's an option. I've talked to friends at Profile Products about some of their soil amendments. So we always brag about using on-site material because regardless of what material you put into this soil cells, the soil cells are actually supporting the load. So as an engineer, it doesn't really matter. You could put A, B, C in there. But as a person that cares about trees, which Pat does, by the way, we want to make sure that we have all the healthy nutrients those trees need, as Ed talked about. So I think it's a case-by-case basis. Let's review what you have there and see what's best for the trees. And it connects back to what Citygreen has available for determining which tree species you need, what the optimum volume of soil volume is for them, and the watering. On the Downtown Denver Partnership, I can tell you watering was a strategic part of that whole plan, where it used to be up to the individual building owners to water the tree in front of their property, and we saw where that got us. A lot of building owners, not because they hated trees, they just had other things on their mind, they didn't do it. The city and county of Denver now have a strategic plan that successfully waters all those trees in the event that they go through a drought time and they don't just get enough rainwater. So something great to talk about, site specific, and we're going to do everything we can to give the trees opportunities to thrive. And I think that ends our time. Oh man, I'll keep going. I tell you what, I have good chemistry with Ed, so we'll roll through one more. Oh, it was just Pat. Thanks. Nice webinar. Thanks, Pat. I hope to run into you soon. And I think, Ed, we covered all of it that I wanted to. We're good on timing. So any last parting notes from you, Ed?
Just really want to say thank you. I think one of the key, I love my job. I just, everywhere I go, what I see is educated, dedicated professionals trying to do the right thing. And, just the amount of planning and the amount of coordination that goes into any one of these projects. It takes a lot of work. It takes a lot of patience. And so we're here to help, let us know how we can assist, and just lean on us in terms of, the vast wealth of experience that we have across the board in terms of these projects and the challenges that we've seen over the past 25 years.
Excellent. Thank you, Ed. Do you see what I changed my screen to for next month's webinar?
Yes.
Okay, for some reason I wasn't able to advance the slideshow that we were in. So everybody, if you use your phone, trust me, this is a good QR code, not one that you'll find in the bathroom of a public restroom. Our company does a lot of in-house training. I can tell you, here's what it pulls up. It pulls up a link to next month's Technical Talks webinar with my friend Rachel from Profile Products, and we'll be live together in Denver for that one. So please register for that and join us. And then finally, just our contact information, so it's on the screen for the video. That's it, Ed. Thank you very much. I appreciate you. And you and I are going to talk very soon.
Sounds great. Thank you, Bill.
Thanks, everybody. Take care. Bye.
Take care.